Hello, hello, hello. So you can sit down. Please sit down so we can start. We are almost ready. Cesarebassofacile.it, MLOps.
Ah, sì, lo so.
Now we have the last two talks. Then when the talks end, don't leave because we will have a small aperitif. Beer, food, and whatever is left, we will keep it. And you have to finish before leaving.
No, periferico bloccato. Just one second.
Pagnani, Chiocciola, Seavino, Tattino, Grow, l'abbiamo messa alle USB bloccate per poi settendare sui manuali.
Ah, quindi niente che posso.
Vabbè, ma sono fatto mandare qua. L'hai mandato?
Non può farlo, no?
Non mi sta prendendo le...
Neanche quello esterno.
Sì, io la prendo, non per quando c'è la scelta. Perfetto.
Mi siede sotto qua, vado di là.
Il puntatore, la USB.
Ha ricevuto il file.
Ah, ok. Il dongolino si è rubato Pietro. Quindi Piero. No, Pietro. Il dongolino. Quello che c'è il
Questo?
No, c'era il connettore, quanto ho capito da
Ah, no, ma lui ha l'USB bloccato. Ok, ma si sente? Can you hear? Ok. So, we switch topic from flying robots to MLOps, and I leave the word to Cesare, that is a data engineering manager at Facile, and please welcome him with an applause.
Thank you, Marco. Thank you, everyone. So today we are going to talk about MLOps. Who knows what is MLOps here? More or less? No. Okay. Is it working? Okay. I am Cesare Bassu. I work as a data engineering manager in Facile.it. Facile is a comparison website which allows you to compare a lot of stuff like mortgages, insurance, loans, utilities, bank accounts. This means that we have a lot of data since we are the comparison leader in Italy. We have a lot of data, and we use this data to make a predictive model, like a lot of digital, native digital in companies in these years. Okay, today we are going to talk about ML engineering, which is the practice of applying software engineering principles to develop, deploy, and maintain machine learning models. Why do we do machine learning engineering? Because we are a little company, we are a little data engineering team, but we have a lot of data, and we should make a lot of predictive models, but we cannot afford to use to have, for example, a specific data engineer for 2 or 3 predictive model, but we have to scale. And how do we scale with ML engineering? The steps to productionalize machine learning models are always the steps that we know since 10 years, 15 years. We train a model, we package a model in a Docker image. We validate the model, which is the data scientist phase, let's say. We deploy the model into production, and we monitor the model. The process is standard. Today we are just going to talk about the standard phase to productionalize predictive models. Okay, how do we do it? We have 3 different branches. We have the dev branches, where the data scientist create the model with production data, let's say, but in a development branch. A test branch, where we integrate, for example, an API with the utilizer of the model, and then we go in production in the main branch. As you can see, we are using 3 different Google Cloud projects. And in each project is separated, so they don't talk with each other. So we are sure that once the model goes in the the higher level of production, we are confident that the model is safe. Okay, the development and the test branches work with the merge part. Instead, the first time that the model goes into production, we use that tag, because we want to have a manual, only for the first time, a manual okay from the data engineer. Okay, every model need an infrastructure. For example, we are in cloud, we are in the Google Cloud, and we need a bucket, a dataset, an artifact registry to put the the Docker images, and we create all this stuff using Terraform. So Terraform is a infrastructure as code tool, which is multi-cloud, and we create all the thing that the model needs using Terraform, but not only, also using GitLab CI. So whenever we have to create a model, the only thing that the data engineer has to do is to put the three thing. One is the name of the model. The second one is the business unit, for example, mortgages or insurance or something like that, and then the state of the project. Which is here the big pro, that no typos could be done in production. Because once you have a single tool with the continuous integration that makes all the work for you, you won't have typos, so you cannot have errors in production with let your system go and crash. So after the CI, we have the same resources for dev, test, and production environments. It means that the code will have the same name of all the the resources. We created. Now we are here at the core of the process. So we create a model skeleton. What does it mean? We create a pipeline or a repo, a GitLab repo in Python, which we call model skeleton. All the models must refer to the same skeleton. Why we did this stuff? Because at the beginning of the data team, what happened was that we had predictive models. Then we had to do a similar predictive models, and so the data scientist or data engineer just copied the first predictive models and to copy it into another model, into another repo. Sorry. So here the problem was that if you have an error, this error is propagated into all the predictive models that you have into production. So we created a single repo which is called model skeleton, and then all the models are a copy of the single skeleton, plus a set of customization that the data scientists can do. With Terraform, all the required resources are created. In this case, all the repos could find all the resources. We use Python. How is it possible to have all the models with the same code of the skeleton? We don't copy by hand, but we use a library which is called Cookie Cutter. Cookie Cutter creates a copy of the code into another, let's say, repo, and it's nice because, for example, it asks you what is the name of the model, what is the okay, and it creates all the structure and all the code of the predictive model. After that, in our model skeleton, we created a set, for example, of algorithms that can be used, for example, XGBoost or IGBM or I don't know. And Cookie Cutter asks you for which model you are going, which algorithm, which library are you going to use to create your predictive model. For example, if you put XGBoost, then all the part of your code of your model are going to refer to XGBoost. After that, the data scientist must define a set of configurations. For example, the table where the data set is stored, or the set of feature splitted by Boolean, integer, or categorical, so string. And in this way, a model is automatically created, and the code is automatically constructed. But what happens when you modify the skeleton? So or for example, it can happen, but if you find a bug in the skeleton and you have 20 models into production, of course, we don't go model by model to fix it. In this case, another Python library helps us, and it's called Craft. Craft is a library which tells you how far is your code from the skeleton. So once you fix the skeleton, using a command, which is a craft update, it automatically creates for you, let's say, a merge request with all the changes that you have done in the skeleton. This is cool because it doesn't work, of course, only for the bugs, but it works for the mainly for the new features. For example, you add a new feature for all the model, data analysis, automatically data analysis step, for example, and it is automatically propagated into all your models in production. So try Craft. It's very cool. Okay. How do we handle our production models? So in this case, I'm talking about a single model. We use a Vertex AI, which is a Google Cloud Platform service to handle all the predictive models and their pipelines. So every step of the pipelines. This is inside a Google Cloud Platform. It is now adding new features like generative AI and so on. So it is easy to integrate into the whole infrastructure. We use the main component of Vertex AI that we use is called pipeline, which lets you create a pipeline. And I know it's shocking. And for example, you have different steps. In this case, we can see the first step, let's say, component is create a BT table, which creates, the data set. Then the data set with the get data is split into train, validation, and test. So very, very standard pipeline in this case. The training, all the free data sets go in the feature engineering in order to let's say to make the first steps of the feature engineering that you want to do. For example, only calculated by the training set, but then applied also in the test and validation. And also the explore data, which is another step which automatically creates a report, a PDF, with all the automatically analysis of all the data set that are given as an input. And this is cool because it creates a PDF and it automatically uploads it into Confluence in our case. So every step is every retraining in this case is documented also in the wiki. So you don't have anymore the business that asks you which version was the model in production and so on. We have a training pipeline. The first part is the part that we just saw. After that, we have the model train. For example, in this case, in the model train, only the training and the validation data sets are they go inside the model train phase. Instead, the test set goes only in the model evaluation. So we are pretty sure that we don't have any kind of let's say bias overfitting, steps. After that, an artifact is created, and this artifact is used to create a feature importance, to create to go inside the model evaluation, to create all the KPIs like precision, recall, and so on, and the size calculation, which is a step where we divide the prediction into the size and then evaluate the model inside. After that, there is a model upload phase, because in the serving pipeline as an API, we have a new artifact that has to be uploaded. So the training pipeline is this part. After that, going back, the one of the question that Cookie Cutter asks to that engineer is it a API? So it is a real-time predictive model, or is it a batch model? So if it is a batch model, it's very, very simple. Every time we want to use the model, for example, daily, if it is scheduled daily, the model just creates the ABT and create the predictions. If the API instead is chosen, then automatically an API is created. And since the data scientist scientist had to specify the integer columns, the string columns, the Boolean columns using Pydantic, which is another Python library, an API and fast API, an API is created, and this API automatically takes as input, all the feature of the model, and put the responses in the API. Okay, going back to the training pipeline, the explore data phase automatically creates a report. This is only one, for example, only one feature and only one of the analysis of the feature. In this case, we just see the distribution of training, validation, and test. We have two different Y axes because the validation and test have less data, so they are in another axis. But in this case, this is the gender, a gender variable, a gender feature, and we can see that that there is no difference between train and the training set and the other sets. Okay, how do we handle the automatic retraining? This is a pipeline. We can schedule again this pipeline, and this is a simple way to have a model always retrained. Automatically, it creates a new Docker or a new artifact, puts into production using all the API, and yeah, this is a simple way. For example, you can do it monthly to retrain a model. Or another way is to do is as a triggered retraining. For example, we calculate daily a set of metrics of KPIs of the model. For example, AUC, precision, recall, and if some of these variables are under a threshold, we trigger all the pipeline, which creates the new artifact. The model is retrained and goes into production. It is important that sometimes the scheduler retraining is the best choice. This is the case when you have a ground truth that comes after a long time. For example, I use a standard model like a churn model that anyone has seen. And for example, if you have a churn probability in 2 years, okay, if the model is degrading the performance, you cannot wait 2 years. So you have to schedule, for example, every month, and this is the best way to have the model always trained. The gate data the data part is pretty cool because when you before splitting the data set into training, validation, and test, creates automatically a JSON of which contains for the domains of the features. For example, in the category, you can see I took a set of bank variable, all the values that the variable can accept. In case instead of a float or an integer, you see the minimum value and the maximum value. Why do we have to do it? Because in the training phase, we create the JSON, but every time we make a prediction, we see if any of the variable is inside the domain. If the variable is not inside the domain, it means that or the variable is wrong, and it can be, but more often happens that the model is not retrained. So in the training set, there are values which are not anymore fresh. Okay, how is it made the batch version? It's in the get data and predict phase. We have a validation phase with the JSON that we just saw, and it just creates a set of results and put it into a table. After that, we have two columns. The first one is the after the prediction, we have two columns. One of that is that the valid prediction column, which tells you if the model has variables that are out of the domain. And the second one tells you the detail. Why it is important to have the detail? Because you can make a dashboard and you know which variable is out of the domain. Okay, I stop.
Can you hear me? Yeah. So thanks. You were super punctual. Are there any questions? First one from the upcoming speaker.
Thanks, Cesare. Nice talk. Two questions for you. The first one, I saw that you have a dev environment as well as a prod and a test. Are the data the same between the three environments? And yes, if yes, how did you replicate the data, or what?
We just have views for the lower environments, so we can train data in the dev environment, but with the production data, so the real data.
Beautiful. And second question, I didn't maybe get how you deploy models for streaming. Do you use Vertex AI endpoint, or is another a Vertex AI?
Yeah, we the API. Sorry. I hope it's here. In Vertex, yeah, in the model serving part, I suppose, we use the automatically the endpoints.
Isn't that so expensive?
Yeah, it is.
Oh yeah, just to know, just to know. Okay, so you're doing no.
But
it's not a critic.
but it
It's
is,
actually
yeah.
curiosity. Well done. Yeah, nice.
Yeah, but it automatically escalates the number of machines, so it's very, very, very good. And also the you have all integrated the part of the monitoring, so we prefer the part of the and after that another point that we like about the of Vertex endpoints is that you can you have a model repository, and you can choose which one you want to use and also split the traffic. So when you have another model, sometimes we put, for example, 1% traffic on the new endpoint, and if no error is raised, we go on with the production, and this is one of the big pros.
Well done.
Thank you.
That 1% is when you don't trust the data scientist.
Yeah.
You want Next question.
Thank you for the talk. For many model, you need, in many cases, you need to know why the model give a particular prediction. For example, if you have a model that give credit, if you give credit, you want to know why the model choose. How you manage explainability of your model if you have these issues, of course?
Yeah, we don't have it in any model. Maybe in the one which are via API, for example, where is everything automatic. We don't use the explainability because we have maybe another process that uses the outcome. But in general, we use a SHAP. So we take, for example, the top N feature, which makes you the prediction. I don't know. The 5 most important SHAP values, and put into a string, which goes into a list, which goes into BigQuery, for example.
Thank you.
Ciao. You're not scared about using like a proprietary system in a cloud that, I don't know, tomorrow will change and you have to adapt your completely pipeline. Like, for example, I saw in the past with Azure, It happened to me, so that's
Yeah.
why I'm asking this question.
Yeah, it's a very, very nice question. But all the code is tested. We have all the code in the model skeleton. So here, tested. So our function are all just Python function. After that, we have another folder into a repo for the creation of a pipeline. So if you want to move from Google to Azure, for example, you only have to change the pipeline part of the code, which is a let's say very, very easy part of the code, because you only have to say, okay, this is the name of the pipeline, this is the Docker image of the pipeline, and this is the code, and you just point to the Python function. So it's like a very, very little part. So we don't have this big lock-in for the pipeline creation.
Okay, thank you.
Other questions? Yeah.
Yes. Hi. You mentioned you use the promotion to production via tag.
Yeah.
Does it also happen during retraining, or once it's been promoted, it will always go directly to production?
Yeah, after a check of the for example, AUC precision recall of the metrics, after a check which they are better of the one into production, we change it. Yeah, but for the critical model, we'll still have the
so
tag.
there is a manual review process.
Yeah. But only for the critical model. For the other ones, the retraining is always better than the model already into production.
Okay, thank you.
Other questions? I have one. I mean, you try to put together plenty of best practices, but did you have some bad story in your experience of something that went wrong or made you have some headache? And what can go wrong with your setting?
Okay. The cool part is that if you test the model, test the skeleton, if you test the skeleton, you cannot have problems into production because everything is tested. And this is the cool part. The bad part is that the first model or the model skeleton creation is long. So it takes months. And it's an investment that a company could make. But after that, we are a little team of data engineering. So we can have a lot of models in production, and we feel safe, let's say, because of that. But the first time that you have to make a model skeleton is a problem. After that, another headache is when we had to do it for not the predictive models, but for the forecast models, which have a completely different shape in the pipeline, because you don't have validation tests like this. You have a timeline, you have different automatic analysis, and we have it, and it had been a very long thing to do. But and now we are going to do maybe the same for the generative AI part, which is completely different of that. So we are trying, let's say, to create clusters, but the creation is a long path.
And then there are no more questions. I have just one more. Since there were some questions about the cost, did it happen to you that you were running a model in production and then you say it's too expensive with respect to the value that it brings, and so we shut down a model?
No, because we have this cool thing which is called Terraform, that has a feature which is called labels. So if you label everything you create,
The assets.
If you label the data set, the storage, the artifact registry, and the API with a label, let's say, you can find in real time the cost of what you are doing, and we have alert in real time for the costs.
Thanks.
Thanks Terraform.
Thanks for Terraform, and thanks Cesare.
Thank you very much.
and suggesting Cesare as a speaker. Pronto, pronto? Okay. I close the door. We are at the very last talk of the day. So only Stefano Siper left us apart from the beer. So you have a big duty. Who is the next speaker? PhD in computational chemistry or something like this. Experience in data science and MLOps. Now MLOps engineer in Synthesia or Scientia, whatever. Please welcome Stefano Bosisio.
Thank you. Thanks very much, Marco. Wow, so nice you hit all the points. Podcast host and podcast maker as well. But this is another advertisement after the talk. So yes, I'm Stefano. And finally, I'm the last speaker for today. I know I have this problem here. As the last speaker, it's 5 o'clock on a Saturday afternoon. So no worries, I revised my entire slides when I found out I was the last one. So they will be at least more interactive, less stressful, I hope. I don't know. Bear with me. And just before starting, today I will be talking with you about this technology called Apache Beam. I'm sorry. It's tutorial-like, there will be some codes, but it doesn't really change. Actually, my talk would like to sparkle some ideas. All those of you that are working for startups or have some ideas in mind might find useful this talk. I'd like to, have clear discussions about possible projects and how to use Apache Beam as a possible tool to close up all your data problem as well as MLOps problem. And so let me see if I can use it. No, the other one, of course. So what we're talking today, obviously, DataOps, MLOps, and what Apache Beam. How to use Apache Beam on steroids, which is either Google Dataflow or AWS Kinesis. There's also the Azure counterpart, but I can't remember the name, so you can look for it. And then we'll jump to the technical side of the talk. So there will be how Apache Beam works in practice, how is an Apache Beam pipeline, how to do data processing in Beam. And since everyone is talking about these LLMs, yes, I'll be talking about LLMs and possible model deployment strategies with Apache Beam. So let's start with it. There's a big caveat in this talk. On Thursday night, I submitted the talk, I sent it to Thao, and obviously Thao say, if you want some internet access, it might be very stressful to ask to the IT people, of course. So the idea was to ask you to connect on Menti, but no worries, we can ask this question in real time. And actually, I already asked this question to another audience. So let's suppose that you have a startup, a project in your mind, and you want to start this new project. In terms of data ops, what would you like to have from a data ops tool? You can see someone very cheerful who wrote OpenF source, all right. But I don't know, what would you like to have from a data ops tool? What's the big? Works in production, yeah, that's very important. I don't know, many people say, production, easy to go to production as well. Cost is implication. They can be easy of usage, and as well as something that data ops is really lacking of is a good way to have a complete data lineage or data tracking, right? We're creating data, but where does data come from? I don't know. I'm sorry, I don't have the tool for it. And as well, always the same scenario. You have a startup or you have a project. It might be $1 billion project that you have in your mind and you want to make it. What are your considerations about MLOps tools? So I don't know, any biggest wish from an MLOps tool? What would you pick up and why? And what are your considerations?
It works really well in production.
That's Jamie.
Easy APIs.
Easy APIs, yeah.
The easy pipeline development.
Yes, of course. So they can be easy. It could go to production without too much hassle. It can also lower down the work made by ML engineers, of course, because I don't want to stress ML engineer in my team just to push something to production. All these considerations are great, and I think they're a good fit for my talk because let's suppose now, let's put this into practice. I thought of a case like I have a startup and I want to evaluate different tools for data ops and ML ops. So we can make under our assumptions. This would be a multidimensional plot, of course, but I just picked 2 dimensions. One is how this tool is data and ML ops efficient. And on the x-axis, the thing I will go for is how easy is to use, but you can say, oh, the cost and so on. And so I start to draft down some tools. So Dagster, by the way, anyone use Dagster? Breaks my heart. There are some well-known PySpark, Airflow also present, Kubeflow. There's Mark over there. Kubeflow lover. So that's nice. The position of these tools is not actually at random. Is all a merit of the data ops and ML ops efficiency as well as the ease of use. So I started with Dagster that I find is an excellent data ops tool. Give it a chance. Next time I talk about Dagster. But the engineering effort to make it to production is a huge, really. And it takes a lot of time to create an easy template that you can send to your research engineers as well as data scientists so they can start working on it. All these tools are great. Airflow, I know everyone knows Airflow, right? You have used Airflow in your life. You can pretend to say yes. Okay, so Airflow, amazing tool. All the companies have Airflow because it's so light. The problem is that maybe it's too light. When we go to production, you must have good engineers to take care of the cluster. Otherwise, as it happened to me, the cluster is basically blowing up and you can't recover all the data processing you were dealing with. The last point is Kubeflow, is something I really love. And in my opinion, it's very easy to use, really. It's no-brainer because you just need to use 2 decorators, pipeline and component, write in Python, and the job is done. And I think it's actually excellent for training, it's excellent for data processing, maybe not so good for going to deployment. So once you train the model, there are some obviously nice tricks that you can use to deploy the model. Kubeflow maybe is not the best, but still, we're there. And here I would locate as well Apache Beam. So ease of usage, and it could be a good combo with Kubeflow because it could have a great data ops as well as a great model deployment solution. So here we go. So what's Apache Beam? Apache Beam is an open source tool. So open source just means that you can freely browse on their GitHub repo. You can contribute to the repo. You can also fix these CI errors they had, which was at the time of the snapshot was a bit say, oh, well, I hope nobody will notice, but that's right, happened. It's a unified programming model. So what does it mean is that in many companies, we are browsing from, I don't know, Python to Scala to C++ maybe. Apache Beam say, you know what? I give you either Java or Python. You pick up one of those, you write your pipeline, and that pipeline that you wrote is enough to go from dev to production. No need for additional engineers to modify it. You're free, ready to go. And it allows you to do batch streaming data processing. What it means is batch is a big single job of data processing. While streaming, you can ingest data in real time, do some data processing in real time, inference in real time. And what is good, in my opinion, if I were a startup, is that I can pass from Python directly to the business value, the results. Many times we're struggling in giving a value to our data. So maybe this is a very simple prototypization of a code, a prototyping of an idea, and we can jump immediately to the results. So this slide could be a take-home message for you about Apache Beam and why I consider it as a valuable solution to consider for all the projects that we have in our minds, beautiful minds, as a powerful abstraction. There's no level details in the code. You don't have to care about CUDA or, I don't know, Scala itself. Why? It's so painful. As unified programming model. So as I said, either Java or Python, no ML engineer in between. Of course, there will be an ML engineer. I need my job, but at least no immediate problem if you're alone in your company and you want to do something really valuable. And flexibility. That's something always missing in many tools. I would like to create a code, a simple code, a template that I could give it to you and you can start working on it. You can modify, you can use Copier, you can use Cookie Cutter, and have it done on your repo, and you can start working on it. Now, we can even go even further and put Apache Beam on steroids. Now, I'm in love with GCP, but not sponsoring any GCP product. But Google Dataflow has made something to me. It's the same as AWS Kinesis Analytics. So Apache Beam can easily run on this GCP service, which is called Dataflow. Dataflow, as you can see, sits right in the middle of your data. So on the right side, you have all your data sources. So it can be a table, it can be a publisher subscription system. And Beam, with Dataflow, process all your input data and give you immediately value that can be going to the custom sync. Now, the good thing is obviously it's a serverless technology, so you don't have to worry about Kubernetes and all these tricky things. Don't worry about nodes. Scalable, it does the scaling. You can control actually the scalability of Dataflow as well. And fully integrated not only with GCP, but from my experience with any kind of API or tool you have in mind, it's very easy to make it work with anything. So that's a very great, a great product. And what I like most in Dataflow, guys, there we go, a pipeline graph. Finally, someone can show me a pipeline graph. So you pass from the code to direct visualization of your code. This is how a Beam pipeline looks like in Apache, in Dataflow. And you can have also a lot of specifications, a lot of metrics. Not only you can pick up a single component will have some specific metrics. For example, here, the number of elements processed by second per second, and as well as the number of output that we have per second. Or you can even go into the nitty-gritty details. You can have the CPU utilization, the memory utilization, you can have CUDA information. So as you can see, we already have a monitoring system in place without actually creating a monitoring system. Many times I had to deal with Grafana dashboards or tricky alerting systems. They say, hey, Stefano, you're spending so much money. No, this time, finally, it's all done. That's fantastic, isn't it? So, and this could be even a way to easily deploy a pipeline using Dataflow. So what usually happens is that you write your pipeline in Python or Java, but we're talking about Python, so today is Python and tomorrow will be Java. There's obviously a CI/CD process in between. You need an image to be created, but Dataflow can easily pick it up, spin up an instance for you, job done. I got immediate value about directly from my input data. Now, yes, this is the end of the light part of the talk. Now we're jumping to the technical side. Hold on, the beer is there, it's almost there. So can we see how is an Apache Beam pipeline in reality, please? Yes, of course we can. So here, a little bit of codes, but just to show you how it's easy to code up in Apache Beam as Python Pys. So of course, the first element we'll need is, guess what? Import Apache Beam. So import Apache Beam as Beam, as well as some additional imports that can be some input-output functions and what we call pipeline options. Pipeline options are like, if you're running on cloud, they can specify the region you're running on, or if you're running on CUDA or CPU or on specific machines you want to use. And then we'll need an interface function to have our pipeline. So a simple run function that as some input arguments are going in. Of course, if we have some input arguments, we will need a parser. So you can choose the parser that you want. Here, there's argparse. You like not, you like yes. All right, no problem. You can choose whatever you want. Parse the input arguments. Otherwise, the pipeline is pretty useless. And you can set up the pipeline option for your current pipeline. And then what we have finally here is, ladies and gentlemen, the pipeline in Beam. So how does it work? Simple elements. The first one is a context manager, which opens up the pipeline object. And then we have all the pipeline steps. As you can see, it's pretty interesting to see how the pipeline is written, because you have the pipeline object P, a pipe, the name of the pipeline like read, and then the function that the component is actually running. Some components are pre-compiled, pre-baked in Apache Beam. Some others instead are created through this beam.pardo and following a function. So the function in the pardo will be called a do function. And now I think this morning Andrea talked about this. We made a step back of about 30 years, and we're back to Fortran to exactly understand what's going on under the hoods of Apache Beam. So I said, this is the pipeline object. And here we have the steps or transforms, as it's called in Apache Beam. So that Pardue is, okay, forgive me, but it comes straight from Fortran. So what happens is, suppose you have an input of documents, like thousands of documents. What Apache Beam does is actually to automatically split them into batches, shuffle them, ready to be parallelizable without you to know how to parallelize an object. So you don't have to care about how to parallelize my components. And this is what the Pardue or parallel do is doing. And this was what Fortran was doing in the 70s with Pardue. So all these batches automatically are sent towards your do function. So in the do function, there will be some operation. You're, I don't know, maybe computing some very cool data scientist features like the logarithm of the imaginary frequency of something. And then automatically this will be output into batches. The good thing of Apache Beam is that you don't have also to be worried how to collect these results. Apache Beam will return an object called P collections. The P collection can be a P collection of strings, can be a P collection of some custom object you've created. We'll merge them for you, and this object will be either going to your output or to the next step of your pipeline. So Fortran is back, and the optimization and the parallelization they put is amazing. So it's really, really on point. Now, can we see some Beam in action, please? Of course, we can. Saturday, 5:30, whatever, Osmo Easter time, so why not? I thought of dividing two parts. The first one is a data ops one, and I thought of a case. So imagine we have a website, a fantastic website, where we have a lot of users, million users every day, like a Py4AI actually. So no, you can copy this idea. What we have, of course, on our website will be two type of users, will be scammers and normal people like me. So scammers usually are using specific browsers. They tend to have different IP. They use proxies. There's IP rotation. It's a good way. They use a VPN. And also, especially, they might have some login pattern to overcome your simple rules to avoid scammers to get on my website. Differently from standard people, which, I mean, standard people might use Safari, Chrome, got no VPN because it costs money, or you have a subscription with NordVPN, but there's no advertisement here in YouTube. And also as simple browsing, right? So if you think of these inputs, actually, these are all action, all events from our user, and we can record all these events in our website, and we can process them as a streaming process in our Beam pipeline, and finding a way to detect scammers and spammers as well on our website. In particular, here, interactive moment, what would you think of as a good tactic to find who's a scammer on our website? So something, I don't know. What would you look for? Mm-hmm. Yeah, whatever. I don't know, like, yeah, graph. So a lot of things, actually. There's an entire field of finding spammers and scammers on the internet. Many of the answers that I had were related to time. And I think time is always not so much used tool in our data ops arsenal. So what I'm saying is that maybe a good thing of Apache Beam and a good feature that we could think of is aggregations. What it means is, imagine that we have our website and we have some users that are navigating on our website, right? All these users are actually leaving some traces or their journey on our website. So this can be like a kind of a Markov chain model. I don't know, they spent X time on this page and then we go here and there, right? What we could do is actually to think to subdivide these events into sub-windows, 60 seconds, 100 seconds, days, little sub-windows. And from here, extract aggregated information. So average of this information, right? So this aggregation could be the time of connection, the username, for example, I don't know, pattern in username they used, login, success or fail. So the good thing of aggregation is that they could immediately give you a level of granularity to find scammers from different standard users. And how do we do this in Apache Beam? Well, that's not so complicated. I'm sorry, it's written not so big, but as you can see at the bottom, there's beam.window.fixed window. We can easily implement a window of methodology in Apache Beam to interrogate our data and extract single subset of data. Actually, nothing prevents us from creating more complicated pipelines and have multiple windows. We could have at the same time a short window that detects some anomalies or sums that are particularly related to some events we know are quite sensible. Or a medium-term window that is sliding across this short-term one. And the long-term, they can be even like Airbnb was using something like 180 days window long to understand the best offer, or anyway, a good level of aggregation. And this could be used to compute anomalies or compute specific moving averages. So what happens here is that we're having a sawtooth window pattern that does the following. So every time these windows are working, they create this sawtooth pattern. And what allows us to do is to use different time scales to understanding long-range correlations or different trends and different correlations in our data. So this is something we have applied in one of the companies I work for. And the good thing is that we had immediately, as in real time, multiple level of granularity, because the short windows, it gives us immediate information about what the user is doing. But the long-term window is able to tell me, wait, Stefano, this might look a scammer, but it's actually your mother find out this website and now she's navigating and say, you know what, mother, who told you about NordVPN? So, and as you can see, this easy way of creating feature, this easy way of aggregating feature led my team at that point to create a feature store as well. So what we were doing, this could be another great usage for you, as we had a streaming of events on our website, and what we were doing was to process in real time with Apache Beam, extract aggregation, extract real current features for any user. And it was easy then to immediately give them to low latency table like Bigtable for real-time inference. So we were doing real-time inference with the latest fresh data, or also send them to a standard table for training purposes, or even to other customers and people that were using those data. So as you can see, we have a good startup. We can find scammers. Apache Beam gave us a good idea on how to create a feature store in a nutshell without going to Tecton or Spark or spending more and more money. Now, here we are. LLMs, we're all waiting for it. So, just a second, let me change my hand. LLMs and model deploying. Actually, this is more about model deployment. On Apache Beam, we can easily deploy models to production. In particular, I took a first example for LLM deployment. So it seems pretty new, this feature, but Apache Beam goes well together with Hugging Face. And what I mean is that you can deploy any model on Hugging Face by simply calling a model handler. Model handler is it's what in between your model and Apache Beam. And as you can see, it's not so complicated to be used, right? You just import your model from transformers. You set up some options, device your CPU, but could be queued up. We could do even more refined things, but just for the moment, it's Saturday again, so no complications, please. And you can immediately use it. You can use it on Dataflow without even spending too much money. Also, you might say, Stefano, that was something already pre-baked by Beam. What if I have my own custom model? All right, no problems, we can do it. Anyone know this GGML repository? Yes, great. GGML, so pick up this book, read it, and the translation is that repository. The guy who made up this repo, outstanding genius, Bulgarian genius, Gregory Jorganov, is a fully optimized tensor library with all the optimization in C++ that you can think of, and has a lot of choice about quantized models. So I say, can I pick up one of those models, compile it, have the binary form of this model, and use it on Apache Beam? And the answer is Yes, you can, of course. You just need to create a model handler. So here, very sorry for the format, but just to show you how a model handler works, there are just specific functions that you have to define so that Beam recognizes them. The important bit here was to create a wrapper on my model, Whisper model wrapper, which calls the model that I was using, which was Whisper, the way how it should start. And then Apache Beam say, bravo, Stefano, well done. I couldn't believe you were doing so great. Yes, of course. Now, an important thing before jumping to the next slide is, great, we talk about startups and ideas for startups, right? And I think this world is not going well, right? Every day we read the newspaper, sad news, like people dying, children dying as well. So without going into politics, the world needs just one thing, happiness, right? And so I thought, could I create a startup that just gave happiness as a present? Yes, of course, we can do it, and we can do it in Beam. So we need happiness. So a few years ago, I ended up scraping some Instagram accounts from politicians, and there was also an interview here. And I say, oh, could I give this caption that I scraped from this politician plus another one that you have to guess who, to a GPT model? I deploy it through Hugging Face and Beam and Dataflow. And yes, I can do it. And the results are also pretty good because, gosh, it looks like exactly as the guy who you could think of saying these sentences. And no more. I will not say, because maybe you voted for him, so respect you anyway. But as you can see, pretty easy, and I could share happiness with the world, so everyone would be happy. And but for international people, of course, we can't talk in Italian. So on the international side, my idea for a startup was to create a fake news startup and have a fake news website. Same thing. So I just gave a prompt to GPT and telling to complete it. GPT through this model handler, GPT through Apache Beam, and Dataflow. And the results are pretty good, especially the last one, which is very, very encouraging. Eating bacon every day is very good. No worries, you can go on with your life. Scottish people would be very, very happy about this. Actually, they were. So I'll jump up to the conclusions of this talk. So you managed to survive, you've seen. I can't see anyone fainted off. And so, yeah, what can I say? So all this talk was just a way to sparkle some ideas on how to do things sneakily, maybe, how to do in a clever and quicker way. And so what we could do is just to say Apache Beam might be looking so promising because they give us a unified programming language. We can even see how to create features and feature stores in real time and for all the usage that we have in our mind. And the most important thing is the rapid prototyping. So model deployment is not such a painful thing. It can be easily done. Please just consider Apache Beam and consider your idea as a possible prototypization for this. Thanks very much for your attention. We managed.
Thanks, Stefano. Questions? First one from a former MLOps engineer.
Lots of questions, you know.
Ask me everything you want. 2 questions if you want. All right.
First, difference between Airflow, in your opinion.
Difference
between Airflow.
Okay.
And the second one, multi-node versus single node deployment.
Oh, all right. Okay. So Airflow, I think is just experience so far from Airflow. It looks to like 7 times to deal with a lot of ETL processes at the same time. So you need a good engineer to scale up your cluster very well. Many times there were cluster failures and you have to recover back. And the Airflow, you know, when it fails, it doesn't give you a lot of tricks or just hints to understand what's going on, right? So that's why I would choose Apache Beam as more stable. I'm not saying that Apache Beam is easier than Airflow. Airflow is a wonderful tool. You can start immediately. I think also if you want to develop an Airflow DAG, it's not so easy to develop locally. Actually, if you want to test it, you should have maybe an image of your cluster or something like that, or a cluster just to dev. The second question was, sorry, I forgot.
Single node versus
Ah, yeah,
multi-node
for
deployment.
Apache Beam.
Yes.
So, say more. Single node versus multi-node. What do you mean? Like, if I want to spin up a job and I want to have a multiple node, or
Like, for example, if I want to have, I don't know, the model MLOps part with the model, and I have to, I don't know, deploy my model. It's working also on a single node. Do you suggest to work on a single node, or it's better in working?
Of course, it depends on the model you're dealing with, because
yes.
on a single node, the scalability is a bit less than compared to multiple nodes, right? But like here, that's a very good statement. For the 90% of the companies that we know, logistic regression, random forests are more than enough to run on a single node. So single node is possible. And also doesn't cost so much as multi-nodes. Likewise, I'll say multi-nodes and data flow, sometimes if you're careful enough, it shouldn't cost so much money. There are some excellent data flow features like Data Flow Prime that allows you to lower the cost of your process.
And lots of questions.
Later on.
Yes.
Other questions? I have one. You have shown how to define a pipeline. What about testing it? What are good practices?
Like many
Test in
options.
production is not an
Test-
answer.
Test what? PyTest? PyTest, for example, a simple test on the pipeline can be done. Now, if I remember correctly, it can be done. There's like, you could even use PyTest to do simple tests on your pipeline and see what's the output. That can be done. Other possible option is that you could use your dev environment or test environment to just spin up a pipeline and see how it behaves. One thing that you're hitting is debugging. Like, I think that when you have an error in Apache Beam, and okay, it's not so clear what the errors is saying, but this is a conjunction of not effort between Apache Beam and Google as well. Because please, if you're using the GCP, please send a request to Google. Is there anyone from Google? Damn, we need them to have a more clear logging of what's
with
going
the
on.
yellow shirt there is from
Yes,
Google.
I remember. I will ask him. More logging, more information. You can't say, "Oh, your code failed." Thank God, I know what's wrong. I will never know. So it depends on what you exactly want to do. How complicated is your task?
Thanks. Other questions? Andrea, you have space for one more if you want.
No worries. No. Don't be shy.
How easy is to add like my super custom code in C++ model? Because you saw you show us the Hugging Face pipeline, but for example, I have my crazy model in C++ and I want to deploy and having, I don't know, HTTP interface on top of that, or other stuff that you, for example, can do with other tools.
Yeah, you're right. Well, it's not so complicated. At the end of the day, what you need is first a way to interact with your C++ code. So I think you must have some Python wrapper or Python interface to deal with. This can be Python or whatever. You can create a package and an image in between that precompiles everything. And indeed, one way to deploy on Dataflow is to use what they call Flex template. So what happens under the hood is that you're baking up this Docker image of your pipeline with all your dependencies, custom dependencies. You pushed it on the artifact registry. And then there's a special command like gcloud dataflow build flex template. They say, we need to use this image. And it's very good because automatically share all your custom code to all the workers that you want, present in real time, no lagging, no issues. Logging still the problem though. If it doesn't work immediately, there's a logging problem, right? But that's part of the journey.
Can I say last one? There are other questions? No, it's fine.
That's all right.
Defining a custom operator. How define a custom operator? No, how easy it is. It's complicated. It's painful. Like, for example, I don't know if there is something that I want to create in my pipeline that is not supported by the official library.
No. It's actually what's Sorry, Rex, I should have given a more thorough example here. But what you need is to define this one. Can I step here? Or is there like some, you should have told me before. Like here, you see, there's a function, which is called do function. What's actually that object is a Python class that inherits the beam do fun. And under the hoods, there's you specify a function called process. And in that function, you create whatever you want, and you can process. The all important caveat: input must be element. Element is the output from your previous step, because input is the P collection, basically. And you can go with the flow easily.
Okay.
Startup idea. Yes.
So if there are no more questions from Andrea, at least, then thank again, Stefano.
Thank you.
So now we can move Sims outside, or if they are done, also inside the lounge. Yeah. Thank you. Oh, wait. So don't step up. 2 minutes and then we move. Andrea, stop.
With a beer.